this just more proofs, or is this related to the test? Anything like that?
I think it's just more proofs.
Okay. All right. So it says here, AD measure of DAC equals BCA. So those are givens. We know that from forever. The last one is almost certainly CP CTC. So like whenever you're proving an angle or a side, you're almost always using CP CTC. Always. Okay. Now we can get into the actual like proof. So this line about the measure leads to that the angles are congruent. So it's like a separate step. You have to say, okay, they have the same measure, so therefore they are congruent. What do you see in the drop down that kind of refers to if they're the same measure, they must be congruent?
Vertical angles,
They're not
something.
vertical angles. It's like because they have the same measure, they are congruent. Is there anything that says like
Hold on.
angles with the same measure are also congruent?
Yeah.
Okay. All right. So something like that, congruent angles, same measure are congruent. Something about. All right. Now, why is AD congruent to BC? Okay, so that's kind of the same deal. It's the lengths of the sides.
Yeah.
Okay, so you see something about that?
Uh,
Like same sides or same length congruence.
yes.
Okay. All right. So I mean that's the kind of the weird. It's like you got to see you have to add that in even though you're like, wait, aren't they the same? It's like, yeah, but you still have to say that. Okay. How about this middle one here? It's AC congruent to itself. What is the reason for that? We've talked about over and over again.
The reflexive property.
Reflexive, yeah. All right. Now I have not marked up the triangle, but maybe you can on your side with the angle that's congruent, the side that's congruent, the side that's congruent, and you can tell me why the triangles are congruent. What is the reason for that?
Alternate. Wait, no.
Nope. So there's four main ways to prove triangles congruent. We write them down over and over again. What's the first one?
Uh, the. Oh, okay.
That's
Those
what we're
ones.
looking for there. So what I'm asking you to tell me without me drawing them in there is what is it? What do you see that is congruent?
Uh, SAS.
Yes, most likely. I mean, it's so AD, BC, AC, and then angle DAC is this one up here, and BCA is this one down here. So yeah, it's SAS. All right. Any questions, thoughts on that?
No.
Okay. Hi. I have a cat that came out of hibernation. Now she wants food. All right. GH parallel to IJ. So that's a given. And the other one is a given. because it's given. And then the last one is always CP, CTC whenever you're proving whenever like a side or an angle follows the triangle, it's always CP, CTC. All right. So we've got angle HGJ, H to G to J. So the one kind of, let me switch colors here. This one up here, IJG, that one there. And so why are they congruent? And this is the Z, I call it the Z. You have to draw the lines without all, or the parallelogram without the lines. And so these are parallel, and this is that transversal. So why are the reds congruent when two lines are cut by a transversal, two parallel lines? What's the reason for that? You actually said it in the previous problem.
The alternate interior.
Yeah, alternate interior angles. Okay, so why is GJ congruent to itself? GJ congruent to GJ.
Reflexive property.
Reflexive, yeah. And then ASA, I don't know what that is. Postulate theorem. I don't know what goes there, but sure there's something. All right. Any questions, thoughts on that before we proceed to the next one?
No.
Okay. This is pretty exciting, right?
Yep.
Yeah. Oh, man. You're going to be done with proofs though soon if you're in a traditional geometry class, like usually right before winter break, you're done. Okay. So first one is given. Third one is given. First one leads to the second one. So if GE bisects angle DEF, so what does that mean about the two angles? Well, it means that they're congruent. So typically when a next step follows, it's the definition of whatever that is. And this in this case is an angle bisector. So do you see something there for definition of like an angle bisector?
Yeah.
Okay. All right. What goes in step 4?
Reflexive property.
Reflective property. Yeah. So even if you don't know how to do the proof, you should be able to get a few steps figured out. And then I'm not sure what goes in the last one there, but you can. Is there a drop down for it, or is it just an empty space?
Yeah, it's just an empty space.
Just a void with a line. Okay. All right. Nope, nope, that was not good. Can't do that. Oh boy. All right. We got another one here. I guess we're just doing proofs today. A lot of givens in this one. 1, 2, 3 givens.
Oh yeah.
Okay. All right. So now number 4, it says angle S and angle R are right angled. So they're referring to these here. Okay. And um, that really comes from the perpendicular.
Yeah.
So what do you see in the drop down there for number 4 about like perpendicular lines meet at right angles, something like that?
Yeah, just definition of perpendicular.
Okay, that sounds reasonable. All right, now triangle PRS and QRS are right triangles. That kind of follows from the fact that they're right angles. Now, just to be clear here, it's this triangle and this triangle. It's not really drawn to scale, but SRP and RSQ. Those are the two triangles that they're talking about. So is there something that says like, hey, if it's got a right angle, it must be a right triangle?
Yeah.
Okay, that's what you're looking for. All right. So QRS congruent to RS, that's reflexive. We've done that a bunch now. Since the two triangles are right triangles, the congruence probably is the one that is used for right triangles. Do you remember which one that is?
Uh, hypotenuse? No,
H followed by, what's
hypotenuse
the other
leg.
one that, yeah, HL, hypotenuse leg. Okay. Any questions of that?
No.
Okay. These really aren't that bad. Like once you get on all the givens and especially when there's a CP, CTC, yeah, it's not bad. Uh, yeah, of course, as soon as I say that, it gets a little bit harder. All right, so we're given that triangle VWZ. Let me do that in red here. VWZ is congruent to triangle YXZ. Now, since they're congruent, you can actually say that like everything's congruent, yeah, sides, angles, all that stuff. Um, Hang on just a second. All right, I am back. I actually don't know what to put here because it depends what we're trying to prove. But we'll get to that. Now, what is the reason for 3? Still with me?
Yeah.
Okay. Sorry, I didn't know if I was still muted. I didn't think I was. But yeah, what's the reason for 3?
Uh, would be
What is up here at the top? What am I trying to emphasize?
the, oh yeah, the given.
Yes, it's given.
Oh,
So truly, like sometimes I don't know how to do these because I'm not looking that far ahead. So I don't know that. Let me move to the other one. Maybe I know that. Now, what we're trying to prove we're gonna come down to the last because I don't know what's going on for here, is that VWY is congruent to YXV, like that. So what are we what would we like to prove it with? Well, in those little triangles, and this is kind of hard to see. In those little triangles, you can see that I'm gonna do this in blue. This angle up here is congruent to this angle here. That could be useful. That is probably our CP, CTC. So YVW congruent to WYX. Is that at all in here? You know, angle V congruent to angle Y.
Yeah.
Okay, that's okay. So that's a good place to start. What else? Well, we're going to be able to prove that this side is congruent to this side. That's the reflexive property. But we're still missing something. We're still missing that angle W. Oh no, that's the one that's given. Okay, sorry. I didn't realize that was already given. Two we already had because it's already given. I didn't see that. So we want to use a different angle, probably angle W down here and WX. So those angles are congruent.
Yeah.
Well, that doesn't help. WV. Oh, I see. Oh, that is okay. All right. So then it becomes angle, angle side.
All right.
Any questions on that?
No.
Okay, I'm just step away for 30 seconds. We'll keep going with number 9. You might try working on it. It's actually pretty straightforward. It's a looks like a well, you'll see for yourself. But let me be right back with you. Right back.
All right.
All right, I am back. Okay. All right. So what did you put anything down here for the first reason
Given.
given? The other one here is angle C is congruent to angle F. All right. Now, A and D are right angles. Um, huh. I mean, it's not given, but I mean, it's in the drawing.
Definition of right angles.
Yeah, I
Is that a
guess.
thing?
Yeah, I guess we can do that. Um, so then the next thing is to say that angle A is congruent to angle D.
Yeah.
That follows from the previous one. So now just remember to use hypotenuse leg, you actually need the hypotenuse. You don't have the hypotenuse in this one, so it's not hypotenuse leg. What else could it be?
Angle side.
Angle side. Good. All right. Any questions on that?
No.
All right, so for number 10 here, let's see what you can do without any assistance. Just put as much in as you can. You may find that there actually isn't that much to do um, after you throw the givens in and the few other things. So take a couple minutes here to see what you come up with.
Okay, so I have all right. Uh, Angles are congruent.
For which one?
Uh, the uh, angle R equal or is
Sorry, let me
congruent
let me
to
let me
angle
let
B.
me label, let me label. Sorry, A, B, C, and D. Okay, what do you have for A? I'm sorry.
Uh, all right angles are congruent.
Good. Okay. B.
And then angle PSQ is congruent to angle RS. No, RQS.
Good. I like it.
Uh, C is the reflexive property,
Okay.
and D is AAS.
It is. Yeah, you're doing a lot of AAS. All right. Great. One more here. Do you have a test or a quiz tomorrow?
Not that I know of.
Okay. Some students do. That's why I'm asking. All right. Same thing here. Let's just have you keep trying as much as you can. You may find, you can get quite a bit of it done without much assistance at this point.
So A is segment AB is parallel to segment DE.
Good.
B is vertical angle theorem.
It is
No
not.
B.
Here's A and here's E. It's related to the parallel lines.
Oh, alternate interior.
Ah, very good.
B is definition of bisect.
So you mean C or B?
D.
Oh, D. C is the A, yeah, AE bisect E. And yes, it's the definition of bisect. Okay, good. Why are the triangles congruent?
Is that vertical angle? Maybe. Oh, wait, it's one. Oh, okay.
It's always these.
Okay. It's one of those. All right. SAS.
Okay. And then why are the segments congruent following the triangle congruent? What always
Diff.
follows the triangle? Nope.
Wait, no.
Look back in the previous ones. There's always, whenever a side or an angle follows the triangle congruent. Like look back at the first one we did today. Maybe didn't catch it in the notes. I made this comment here about sides and angles following the triangle congruence.
Uh, the C, PC,
Yes.
DC.
Yeah, there you go. All right. Is that everything you wanted to work on today?
Yeah.
Okay. We're going to stop early and both can enjoy this being the last lesson until next week.